So I'm going to talk to you about the current status of whiting. I might dim the lights for effect. Yeah. And I can't take all the credit for this. I'm going to point him out. There he is, Andrew Nichols. This is his work. Put your hand up. Yeah. This is all Andrew's work, and I just happen to be his Jedi supervisor. Yeah. So and that sort of thing. And there's a lot of other people in the audience that have contributed to this work. So whiting. First of all, regardless of whether it's whiting or any species, there are a number of questions that we would need to ask if we want to try to manage them sustainably. There are lots of questions we need to know about a fish. How old does it get? How fast do they grow? How quick do they die? How many that die are dying due to fishing as opposed to natural causes? You know? When do they breed? Where do they breed? What size and age are they when they breed? When they breed, how many eggs do they produce? Okay? Is the recruitment from those eggs variable? Strong years, weak years? Are there differences between males and females? And these are just some questions we can ask. And we need to know the answer to these questions if we're going to manage our stocks with sensible management decisions. So the question now becomes, how do we answer these? You need data. You need some data from the species you're looking at. So the next question is, how do I get that data? So step one is to go fishing. That's the happy emoji. Unfortunately for me, step one is sadly to ask someone else to go fishing for you, you know, and ask them to give you, unfortunately, even more frames rather than whole fish, you know. The yummy bit's gone. So step one is fun when you can do it, as you can see here. Has anyone tried to do a selfie and hold a whiting at the same time? It's really hard, yeah? Okay, so sample collection. King George whiting frames have been collected from commercial and recreational fishermen since 2012 from northern and eastern Tasmania. Okay? And they have been collected by rod and line from the recreational sector and from gill nets and rod and line from the commercial sector, and I've been asking for frames and frames have been donated to me. We then get those frames and I've used them in biological classes and also in honours projects where we have measured them for lengths, total lengths, fork lengths. Because the guts are still in there, we can still sex them. So we can determine whether they're males or females. Because their gonads are still there, we can weigh them, and we quite often get both of the ovaries in there, so we can get a whole gonad weight. We then also take a sample of that gonad and store it in ethanol, in alcohol. Take a little sip first, and then put the gonad in there, you know, pickle the gonad. And then we cut the heads open and we get what's known as an otolith out, which is an air bone in the head. Okay? So that's our sample processing. We then otoliths are sectioned and cut, and we age them, and we look at the structure inside it to determine age. The gonads we use to determine our macroscopic staging condition, that's a big word, just whether they're developed, whether they're spawning, whether they're spent, whether they're immature, those sorts of things. And then we can also count the number of eggs within that gonad to determine how many eggs they were producing. So, and that's a term called fecundity. So how do you age a fish? Well, if you're in the fisheries forensics, you already know a little about this, but we actually cut open the skull and get an otolith out. We embed that into resin in rows. You'll notice that the black lines are where the centre of the otolith will be. We will use that mark to cut it with a saw and produce 300 microns, 0.3 of a millimetre thick slices of bone. And we mount it onto a microscope slide. We sometimes polish them on a 1200 grit faceting wheel to make it nice and flat and smooth, so it's really easy to read. And then we stick it under a microscope and you get your students to estimate the age because it's boring, yeah? But you come in and validate it, make sure that he's doing the right things or she's doing the right things. But anyway. So, here is a whiting otolith. The first dot is the core, and then these bands coming up running through here, okay? So this is not our oldest one, but the oldest one was an 18-year-old, and it was a head only, and from the otolith length we estimated it to be a 66 centimetre total length fish. Okay? But over here are edges. Sometimes you can have this white band on the edge. Sometimes there's the white band in a very small, clear, translucent zone. Sometimes there's a white band and a thicker translucent zone, or a really wide translucent zone. When we look at the proportions of all of these zones over time, over months, and this is all years pooled because we don't have enough data, you'll notice that they're narrow, wide, and then all of a sudden in October and November, bang, there's an appearance of otoliths that are all edge. This seasonal cycle of the edge getting bigger and bigger and bigger and dropping in November is annual increment formation and validates that those bands are annual. Okay, if it occurred every month, they'd be monthly. If they occurred every day, they'd be daily. And there are daily bands in larval otoliths and these sorts of things. So what we're counting, we've validated as this being actually annual bands. Okay, so we're quite confident in our age estimates and these sorts of things. So I've got there's lots of graphs today, all right, so I'll try and talk you through it. This is our mean size at age down through here. And this is the difference between males and females. So there is some evidence that females grow faster than males, and that curve is our modelled mathematical voodoo line that tells us what it is, the von Bertalanffy growth function curve. Okay? And we can also, because we know date of captures and margins and these sorts of things, we can turn those ages into a decimal age, okay, and model it that way. So in both cases, depending on which technique we use, we still get the fact that females are slightly growing faster than males. Okay? Although statistically, I don't think we can quite get there. It looks like it, but statistically it's not. When we actually look at our sex ratio from sex here, from the size classes we've got, we can see that if you are large, you are more likely to be female than male. Okay? There could be a number of reasons for this. It could be that males die out sooner and then females live longer, or it could be differential growth and these sorts of things. When we have a look at the sex ratios with age, we see that there isn't that consistent trend, that there's the same sort of ratios, and so it wouldn't suggest that males are dying at a faster rate than females. It would say that their mortality is relatively the same with sex, but females probably grow slightly faster than males. When we have a look at what we've seen across the state, we've got samples on the north coast, which includes Port Sorell, the Tamar, and up and out around Wynyard, Stanley area. Okay, so all of the north coast of Tassie. This is where our predominant sampling has occurred. And this is size. We can see our size frequencies between males and females. A bit more females than males in our samples. And when we have a look at our age structure, we can see here a similar sorts of age structures in through here. Okay? What's interesting on the east coast is that these big old fish are not there. Okay? One of the reasons for this is where the east coast fishery occurs in St Helens is typically a juvenile habitat. Whereas where we're sampling on the north coast, there seems to be a lot more adults around. Okay? So we've actually looked at what the stock structure is. We've got large fish, kilo plus whiting, that is trophy whiting present in the state. Okay? And up to 18 years of age. So now if I break those age structures into every year that we've sampled, this is where I get really excited. The East Coast was a small sample, so we sort of need to ignore this, and we know that it's a juvenile habitat, so it may not reflect what's going on historically. So if we look at this one down through here, we can see these three large trimodal peaks. When we follow these peaks through, we can see that there's similar trends running all the way through, going through here. The numbers above that is the year of birth. This data is suggesting to us we had a major recruitment event in 2001, a good recruitment event in 2003, and a good recruitment event in 2007. It's too early to know what's going on. So you can see this 2001, 2003 and 2007 birth years in through here with peaks. You'd say that, oh look, 2014, 15 and 16 is a major recruitment event. We're going to have a bursting fishery in 3 years' time. Yeah, that could be true. But I've also ramped up my sampling. I've got a lot more recreational fishers fishing for me. I've got a lot more recreational fishers fishing for me in juvenile habitat, such as the East Coast and the Tamar and Port Sorell, which is dominated by those young 3, 4-year-olds. So this could be, this big spike here could be my recent increase in sampling effort for the species. So, but it could also be a really good recruitment of them. One thing's for sure, they definitely have recruited in 14 and 15. So we can see this episodic recruitment. One concerning factor though, also, see this 9-year-old, no 10-year-olds, no 11-year-olds, a few 12-year-olds, no 15-year-olds. Down through here, 7, 1 8-year-old, no 9s, no 10s, no 11s. In actual fact, this year, this birth year here, I think it's 2006, out of 700 otoliths, I have 1 fish born in that year. That is what we call a missing cohort, weak recruitment or failed recruitment. So this is evidence that we've got whiting. Yes, they can recruit and they are self-sufficient in breeding here. We've also got evidence that it's a bit spasmodic. Sometimes it's good, sometimes it's bad. Okay? It could be an emerging species thing. We've had a good recruitment. They've got to adults, they've bred. They've started to spawn. We've got a bigger standing stock of adults. They've started to spawn. Now we've got loads of adults and a bigger standing stock. And now we're getting, it could be an emerging species thing that's coming on. Okay? But only time will tell with continued monitoring. So there's those evidences of these weak recruitment years running through there. Okay? Too early to tell for 2014 and 2018. Reproductive assessments. How do we tell what a fish does? This is, we look at it. Can you see that those 4 pictures are all different? Okay? If it's clear and small, it's not doing anything. If it's big and granular, it's developing yolk. If it's got lots of clear little dots in it, it's maturing and it's going to ovulate that night. It's going to spawn that day. Okay, and then if it's got this running eggs in it, it's ovulated and spawning and you can use it like a water pistol. Okay, that lasts for about 30 minutes, usually on dusk in most species. Okay, ovulated. Very rare to get a picture of an ovulated female. So, when do they breed? We can look at the size of the gonad, big, small, relative to weight, and create an index called a GSI. This validates what we're seeing macroscopically is true and our numbers are right and it validates our age, our reproductive studies. Look at these numbers. 259 immature non-reproductive fish, but only 39 yolky fish and only 2 fish that we can say are spawning. No ovulated fish and 9 spent fish. But we're seeing that there's an increase in this GSI. So this sort of says, yes, your macroscopic staging is good, but your numbers of your stages, of various stages, are variable. When we look at this GSI seasonally, we can see something really interesting going on. Increasing January, February, the gonads are getting bigger, right? They're putting in more yolk into their eggs. They're getting bigger. And then in April, it drops. And then comes back up. And so this is really weird. This is weird. This is just wrong. This doesn't work. I don't know what's going on. And we can sort of see a similar trend in through here. But as we know that most whiting move offshore in deep water to spawn, from South Australian research. Okay, what we suspect is going on is the blue line is what's probably going on. But because no one's fishing offshore and giving me samples, I'm not getting them. Okay? And because only the juveniles and the immature fish are in the estuaries at those time of the year, the GSI drops because it's all immature fish or just adult sized fish that haven't left yet. Either way, we can say that it's likely that spawning of whiting in Tasmania is likely to occur between late March to June, based on what we can see. Okay? And that's consistent with the species and what we see in other states. The fact that we've actually got hydrated, we've got 2 events, we could have had a lot more, but the students didn't keep that. Anyway. There's someone up in the... They'll know I was digging at them. Anyway. So we have evidence that they are spawning in Tasmania. So we do have a reproductively active population that is providing recruitment, we suspect, to Tasmania. We can look at it from a stage perspective, and a GSI we see inactives. This shouldn't be GSI, this should be percentage, sorry. We have inactive fish being in high proportions and dropping out. Vitellogenic fish increasing, this is ones with yolks. The hydrated fish are absent. So we don't know where they're spawning. This is what the data is telling us. And then they're spent in June. So when we look at that, we think, well, they're increasing yolk, they're probably spawning around here, and we get spent in June, so that's what validates the April to June sort of spawning. And we get the same thing with male. Interestingly enough, if we look at mean size of our data on months, we get high, 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 May, bang, down low, because all the adults have left. And it stays low, and then it bumps back up. So it's really consistent in what we believe is happening with King George whiting.
3 minutes.
3 minutes, no worries. Looking at size, the dotted line, by the way, here is our total length, minimum legal size, 35. Now, the smallest female that is even capable of producing any eggs is bigger than that. So the minimum legal size is targeting virgins at the moment. However, it's also the largest in the nation. All right? We can see here that realistically the minimum, the size of GSIs doesn't really increase until about here, but I don't have a lot of animals. I don't have animals in May to do a robust size at maturity modelling curve to do it. So there's insufficient data to model the size of maturity. The smallest female was 36 centimetres and the smallest male was 355, which is much smaller, which is larger than the current minimum legal size. When we look at age, we can see here that some fish will mature at the age of 3, but not many, whereas really at the age of 4. So first maturity in whiting in Tasmania is occurring at the age of 4. So you may want to think, if you want to actually let them spawn at least once in their life cycle before they actually become sexually mature, before they become exploitable, okay, then you would probably want to put first capture at 5 years of age. Okay? 4-year-olds, first virgin spawn, measure 396. 5-year-olds at 1 year of spawning before exploited is 442. That's a large whiting. That's a really large whiting. I've not caught many up there. I don't want to do that. I like my whiting. Okay? So, one of the things is, because we are not exploiting at the moment our spawning stock, the large spawning stock, we're not targeting it, no one's fishing it, we don't know what's going on there, there is a large sort of biological closure of the spawning stock at the moment, which is great. It's fantastic. Once they've gone, they run away from us and do it privately, where they're not exploitable. That's fantastic. It's beautiful. Okay, so in that case, because of there's that there, the current size limit, in my opinion, is probably pretty nice. Okay, but we will always need to continually monitor it in case behaviours of fishes change. With that, I'd like to thank Professor Greg Jenkins, who provided me some data from 2012, Andrew Nichols, my honours students, Craig, the commercial fisherman, and a number of recos that provided me samples. Without their help, it wouldn't have been possible.